Okay, so this is Core Pure 1, June 23 paper on the Edexcel, and it's question 5 I'm going to look at, which is a vectors question. Quite a complex vectors question as well, loads going on in there. And as with all vectors questions, well, not all, but you know, there are several ways in which you can go about each one. So I'm just going to show you a way I would approach each one. I'm not saying that it's necessarily the most efficient way or whatever, or the first way that it will be on the mark scheme, but it's the way I kind of logically see these things as I'm working through. So this first one, we have a line L1, part A it's a nice start actually. The L1 has this equation, x plus 5 over 1 equals y plus 4 over minus 3 equals z minus 3 over 5. And we have a plane pi 1 that just simply has the equation 2x plus 3y minus 2z equals 6. And the first job is just to find the point of intersection between the line and the plane. So obviously if you've got your plane here and you've got your line coming in, there will be a point where they meet. Okay, in fact I'm going to draw it here. So probably the easiest way to do this is to write these, well, this is the way I would go, write that line and write that plane in terms of vector form, r dot n equals a dot n for this one, and r equals a plus lambda b for this one. So let's deal with the L1 first of all. So r equals, and you can go through and you can see a point that's on the plane is it's x minus a, y minus b, you see. So it's going to be minus 5, minus 4 and positive 3. So minus 5, minus 4 and positive 3. That will be, did I say the plane? I meant on the line. That is going to be a point on the line, and then the directional part of the line is your 1, your minus 3 and your 5 on the bottom. So hopefully we all know how to get that from the Cartesian equation to the line of plane, just picking out our point on the top, and on the bottom is our directional part. So 1 minus 3, 5 is our directional part. Okay, and then if we take pi 1, that's much easier. We can see the normal part of our pi 1 is 2, 3, minus 2. So it's r dot 2, 3, minus 2 equals 6. Oops, there we go. Oh my word. Can't even write 6. There we go. Okay, so if we want the point of intersection, we just need to put the equation of the line in for our r with the equation of the plane, find what our lambda is. So I'm going to write this as minus 5 plus 1 lambda, so minus 5 plus lambda, minus 4 minus 3 lambda, minus 4 minus 3 lambda, and 3 plus 5 lambda, 3 plus 5 lambda. Dotted, so I'm putting it in there for the r with 2, 3 minus 2 equals 6. Now we can just multiply along, so we're going to get 2 times minus 5 plus lambda, plus 3 times minus 4 minus 3 lambda, minus 2 times 3 plus 5 lambda equals 6. And then all you need to do is work through that and get your value of lambda. And to save us some time, I did that earlier. What did I get? I got lambda equals minus 2. Okay, so now my point of intersection I can just plug that minus 2 into here if you like and work out what the equation of the point is. So we put minus 2 in there, so minus 5 times minus 5 plus minus 2 times 1, and minus 4 times plus minus 2 times minus 3, and so on, and we got our point. And that works out to be minus 7, 2, minus 7. So just put lambda equals minus 2 into there, boom, there's our point of intersection. There we go. So that's quite nice. Okay, point of intersection done. Just 2 marks that, I'm afraid. Not a great deal to it, but a bit of working though for 2 marks, but not a great deal of theory. So part B says the line L2 is the reflection of the line L1 in the plane B1, pi1, sorry. So here's our L1. So we're reflecting L2 is a reflection up there. So what we need to, well, what I will do this, we need to find the vector equation for L2. And we need to show that L2 is going to have the vector equation of R equals -7 to -7 plus mu 10, 6, 2. So we need to show that that line, which is a reflection of that line, has that equation. Okay, so a couple of things to point out. Firstly, they've been quite nice here because that -7 to -7 is immediately telling me, oh, I've got that part A correct, because surely where L1 and L2 meet is that point there, the point of where the L1 hits the plane. So L1 and L2 meet where L1 and L2 hit the plane, and sure enough, in their answer that we're trying to show, that's a point on this line, L2, and it just happens to be the point where we've worked out that the L1 hits the plane. So it's almost kind of telling us, well, you got part A correct. So that's nice. It's an immediate check for us that, oh, everything's gone all right in part A. Now, if we know that point is -7 to -7, that's our point on the line, L2. So all we need now is the direction of L2. Now the easiest way to do that is just get another point on L2 and do, how do I get from that point to that point, will be our direction of L2. Now, getting a point on L2, we basically need to kind of go, well, can I get a point on L1 and reflect it up there? Oh yes, I can. And I know a point on L1 because I know the equation of L1 is this, and so there's a nice point on L1. I know on L1 we have the point -5, -4, 3. So what I'm going to do is I'm going to reflect that point up there into L2, and then I'm going to use that point and that point to get my directional part. Okay, and that's all I need. I've got my point on thing, I just need this directional part. So I'm going to reflect this point, the -5, 4, 3. I'm going to give myself a bit more space if that's okay, so I'm going to rub this off. I'll leave that up there. Okay, so if I reflect that point up to there, the first thing I have to realise, if it's a reflection, this line joining the point with its reflection is going to hit the plane at a right angle, shortest distance basically. So what I now need is the norm. If it's hitting it at a right angle, that means it's going in the same direction as the normal of the plane. Now the normal of the plane is just 2, 3, -2. So I'm going to get this line that joins the reflection point, the equation of this line first. So you'll see what I'm going to do here. So it's the equation of line joining this point, -4, -5, -4, 3, with reflected point. So the equation is nice and simple. It's just R equals, point on the line, -5, -4, -3, plus T lots, I use T this time, we can use whatever we like, of a directional line, and I know it's going in the direction, same direction as N, so I can just use 2, 3, -2. And now what I've got that equation outlined. I'm going to see where it hits the plane. So I'm going to put that into the equation of the plane, but in its R dot form. So this is minus 5 plus 2t, minus 4 plus 3t, and 3 minus 2t, dotted with 2, 3 minus 2, equals 6. So if I work all that through, multiply these together, boom, 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 get an equation involving t equal to 6. So I'll do a little bit of it, but then we're going to skip and trust that as further mathematicians, surely we can work that out. Minus 2, 3 minus 2t equals 6. So we work through and we get our t value. And I worked that out to be, what did I make t equal to? I made it equal to 2. So, putting 2 in there, this point here, where the line joining that with its mirror is going to be, putting 2 into there, I get minus 5 plus 2 times 2, so that's minus 1. Minus 4 plus 3 times 2 gives me 2. And then 3 minus 2 times 2 gives me minus 1. So that's the point of intersection with the plane, good old pi 1. So now I know this point is there, is minus 1 to minus 1. If I want to find that mirror line, okay, that point there, all I've got to do is go, how do I get from there to there? Do it again, and I get up to the mirror point. So from there to there, and then repeat it, I get up to there. So I tend to, and I know this isn't probably good form, but just go, okay, I've got minus 5, minus 4, 3. If I go to minus 1, 2, minus 1, and then I repeat that, I get my mirror line. So minus 5 to minus 1, I've gone up 4, so go up another 4, oh, I'm at 3. Minus 4 to 2, I've gone up 6, so go up another 6, I'm at 8. 3 up to minus 1, I've gone down 4, so go down another 4, minus 5. So that's my mirror point. 3, 8, minus 5. So, I now know this point up here is 3, 8, minus 5. So to get my directional part of this mirror line, I just go, oh, I go from this point, minus 1, 2, minus 1, to this point, 3, 8, minus 5. That gives me my directional part. So I'm going all over the place here, but I have to rub off to give myself a bit more room, I'm afraid. So our directional part, our line is going to be, if I do some simple subtraction, minus 1, 2, minus 1, and I go to take away 3, 8, minus 5. That's going to give me minus 4, minus 6, and 4. Now, any multiple of that is going to be my directional part. Now, just checking that I've not made a mistake there. 4, 6, yeah, 4, 6, minus 1. Let me see what I did. I got minus 5, 4, minus 3 to that. 3, 8, minus 5. I know what I've done. I've copied that down wrong. That's not minus 1, 2, minus 1, is it? It is minus 7. 2 minus 7. Dearie me. That's better. So minus 7 take 3 minus 10. Ooh, there we go. 2 take 8, I've got that bit right. Minus 7 minus minus 5 is minus 2. So there's my directional part, minus 10, minus 6, minus 2, or any multiple of that. So our equation of our line is r equals minus 7, 2, minus 7, plus what we up to. We use t down there, so let's use s now. S lots of this. Now, they said 10, 6, 2, so that is a multiple of 10, 6, 2. So we can just go, there you go, minus 10, minus 6, minus 2, become 10, 6, 2. Any multiple of that, so we just times it through by minus 1. And we've shown that it's that line is the reflection line. Okay, next bit. Let me give myself some space. So part C, I'll just pull all this down so I can see it a bit better. Right, the plane pi 2 contains the line L1 and the line L2. We need to determine a vector equation for the line of intersection of pi 1 and pi 2. So, let me just give myself a bit more space here. Let's rub this off a bit. See my things. So, for part C, if we know the plane pi 2 contains the line L1 and the line L2, if I vector cross together L1 and L2's directional bit, it should give me the normal vector for pi 2. So I'll just say that again. So we've got L1 and L2, and we've got pi 2 contains both those points. So when you've got a plane like this, and you know there's two lines that are on there, if you take the directional parts and cross them together, get the cross product of those two things, then it's going to give you your normal vector here of pi 2. Okay? So we're going to take our two directional parts. Now, our two directional parts, we know, let me just write out what L1 was again. So L1 was R equals minus 5, 4, minus 4, 3, plus lambda lots of 1 minus 3, 5. And we just worked out in part B that L2 has this equation, minus 7, 2, minus 7, plus, they used mu, 10, 6, 2. So if I dot these together, cross these two directional parts together, it gives me the normal vector for pi 2. So n, which is our normal vector, we do, when we cross together, we do the determinant of our 3 by 3, ijk, so 1 minus 3, 5, and 10, 6, 2. Put that together, so remember you do I times by the determinant of this 2 by 2, so that's going to be I times minus 6, minus 36i. Ooh. Then it's negative j times the determinant of this, cross out that and that, of 1, 5, 10, 2. So that's 2 minus 50, so minus 48. With that it becomes plus 48j. And then k times determinant of this 2 by 2. So 6 minus minus plus 36k. Okay, so that's your n. However, always try and deal with nice vectors where you can. The n can be any multiple of that. So you can see, these all nicely divide by 12. So shall we call our n, divide that through by 12, minus 3i plus 4j plus 3k. Okay. So that's our directional part, our normal vector for pi 2. Now, if we want the line of intersection of pi 1 and pi 2, let me just see, the equation, line of intersection of pi 1 and pi 2. Basically, we now take the two normals that we got, okay? The two normals that we got, this normal here, haven't even gone to the equation of pi 2 yet. So this normal here, and the normal of pi 1, and if we cross those together, we must get a line that is perpendicular to the normal of pi 2 and the normal of pi 1. So if it's perpendicular to the normal of pi 1 and pi 2, it's going to be along the line of intersection of the two. How do I best explain that? I'll try to draw a really awful diagram. So if you've got your, I'll tell you what, I'll do it with 2 pieces of paper. So if you've got your line of intersection where these two cross, if you've got your normal coming out of there and your normal coming out of here, if we cross them together, it's got to be perpendicular to that and perpendicular to that. So it's got to lie on this plane and it's got to lie on this plane. Because if I do find something that's perpendicular to n, it will lie on this plane. And so if I do a vector that is perpendicular to the other normal, it will also lie on that plane. And so therefore it's going to be lying on both planes, it will be along the line of intersection. I don't think I've explained that very well, but hopefully that makes sense. So I'm now going to do the cross product of both normals. So I'm going to do I, J, K, cross product of that normal I've just found, minus 3, 4, 3. And then the normal of pi 1, which was, I've forgotten the equation, I'm going to have a quick look again. What's the equation? Oh yeah, pi 1 was 2, 3 minus 2, wasn't it? 2, 3 minus 2 is the normal for pi 1. So that will give us our directional part of the line of intersection. So if I quickly work through that, again, I times that, so you've got minus 8, minus 9, so it's minus 17i. J's, minus, and then, 6, minus 6, no J's. No J's, wonderful. And then K's, minus 9, minus 8, minus 17k. And again, make your life nice there. It's in that direction, 17's into both, so can't we just call that I plus k? Divide through by minus 17 both, as long as it's in the direction. So, our line is going to be the directional bit, I've forgotten what letter we've got up to now, I think I'm going for S again or something like that. The directional bit is going to be 1, 0, 1. We need a point, okay? A point that is common to both planes. Well, if it's got L1 and L2 in it, and we found the point of intersection for L1 in the plane, pi 1, that point, that minus 7, 2, minus 7, must be on the line of intersection of the two planes. So we're just going to use that. There we go. Point on the line, directional part of the line. There's your equation. Whew, quite a bit to that. Okay. So there's the equation of the line of intersection of both pi 1 and pi 2. Final part, big question this. So, final part is, we've got a third plane coming in. Whew. So, the third plane has an equation, and we know that pi 1, pi 2 and pi 3 form a sheath. And we need to determine the value of A and the value of B, and the equation of pi 3 has this equation. So let me just do this. Pi 3 has this equation, R dot 11A equals b. Now I'm going to straight away turn that to Cartesian. You'll see why in a second. So that's going to be x plus y plus az equals b. So that's pi 3. Now then, remember pi 1 had a Cartesian equation. That was in the question we were given. 2x plus 3y minus 2z equals 6. So what we're doing here is we're actually going to form 3 sets of simultaneous equations. And we're going to use our solutions of simultaneous equations and the implications of it being in a sheath to determine what these A and B are. Okay? So we need our third equation. So we've got pi 1 given to us in the question. We've got pi 3, they gave that as well. So pi 2, we do need the equation for that. Now we know what the normal vector for pi 2. So we're going to use r dot n equals a dot n. We know that the normal vector for pi 2 we worked out to be minus 3 fourths 3. So r dot minus 3 4 3. So we worked that out in our previous part, that that's the normal for pi 2. We need a point on pi 2. Well, good old minus 7, 2 minus 7, we know is on pi 2 as it's on pi 1 as well. So minus 7, 2 minus 7 is our A. Dotted with our normal, minus 3, 4, 3. Dot them together, get your answer, and then write it in Cartesian. So our Cartesian is going to be minus 3x plus 4y plus 3z equals, and when you dot them together you get 8, 21, 8 and minus 21. So yeah, 8. So we've now got our 3 sets of equations and we're going to use the fact that we know it's a sheath, so that's where our 3 planes meet and form a line. Okay, so it's consistent, this set of equations, but there's an infinity of solutions. So let me just write them out one under the other so we got this nicely. So we've got 2x plus 3y minus 2z equals 6. Pi 2, we've got minus 3x plus 4y plus 3z equals 8. And then pi 3 is this x plus y plus az equals b. Right, so there's not a unique solution. Now, because there's not a unique solution for a sheath, it's a line of solutions, infinite number of solutions. That means the determinant of this 3 by 3 matrix here cannot be 0. Is 0. Good. It's got to be singular. So we're going to write out the matrix formed by these 3 equations. So 2, 3, minus 2, minus 3, 4, 3, 1, 1a. And we know the determinant of that has to equal 0. Okay? So, working through that, we get 2 times, what's that, 4a minus 3. Minus, don't forget the minus, 3 times, what's this? Crossing those out, minus 3a minus 3. Plus, that's minus 2. Minus 2 times this last one, which is minus 3, take away minus 4, so it's minus 7. Okay, equals 0. So there we got a nice equation that we can work through and we can find out what A is. Ah, great. So we've got a particular value. And that gives us A equals minus 1. Okay, so now then, we now know that A equals minus 1. So if we go to, we know this, there. If we put our minus 1 in there, let me just cross these off now. we now know the equation of the plane pi 3 looks like r dot, where is it again? Sorry. 1, 1 minus 1 equals b now. So we've got the a is minus 1, just with that. Now, lots of things we could think about now and kind of look at systems of equations, but let's be logical here. We know if it's a sheath, it's a line of intersection, basically, of all three. It's all three planes coming together to form a line of intersection where they all cross over. So if it's on line of intersection, doesn't that mean that that line of intersection must be the same as the line of intersection for our first two planes, pi 1 and pi 2? And we worked out what that is. We know what the equational line of intersection on pi 1 and pi 2 is. We worked out in part C, I think it was, that r equals, let me see, I'm going to find it again. Minus 7 to minus 7, didn't we? Plus, I've forgotten what the other bit was, but anyway, doesn't matter, because doesn't that mean that is on our point of line of intersection? So because pi 1 and pi 2 intersected as a line, and we know that's a point on that line, it will also therefore be a point on the line where all three intersect. Because if all three intersect, form a line, we know two of them form a line, that's got to be the same line that the third one it intersects with. So that point must be on the line of intersection of this sheath. So all we do, be clever about it, just put minus 7, 2, minus 7 in for there, and that will tell us what our b is. We can just do minus 7, 2, minus 7, dotted with 1, 1, minus 1 equals b. Working through that, we get what our b is. So we get, what's that? Let's finish this off. Minus 7 plus 2 plus 7 equals b. Ah, b equals 2. Done. Whew. Quite a complicated question. Lots going on there. And then bringing in the simultaneous equations at the end there. That's a lot to it. Anyway, hope that helps. I know it's been a bit all over the place. There's been so much writing, but it was quite an involved question.